Folks. This is week 4. This is Monday. I pushed this worksheet out to you all last Thursday, and I just wanted to go over it with you so you can kind of see what's going on. And I'm also going to go ahead and introduce covalent bonding. I'm going to post all this stuff Monday night. It's just information because I would like to give a test on Thursday and wrap up this ionic and covalent bonding and diagramming atoms and move on to something else. Basically, trends in the periodic table at this point. So this here was the ionic bonding piece, and I'm going to review again because it may have been a couple days since you've looked at this. These are the boxes that are on the periodic table. This whole number up here is your atomic number, which tells you the number of protons or the number of electrons in a neutral atom. This here is the atomic weight. And because the size of the electrons are so significantly smaller than the protons or neutrons, we basically round this number off to the whole number, nearest whole number. And if you subtract the number of protons, it will leave you with the number of neutrons. Remember that when you round, if it's 6.4 or below, then it goes to 6. If the number behind the decimal is 5 or higher, then you round up to the next whole number, which would be 7. So for lithium, if this is the atomic number, this means that lithium will have 3 protons. We'll also have 3 electrons. Remember that you put 2 in the first energy level. It fills up first energy level. And if you have 3 electrons to place, 2 goes here. That means that the third one goes out here. Remember the second energy level. For it to be stable, it would like to have 8 electrons in it, which would make it filled, and it would also satisfy the octet rule for atoms becoming stabilized. So the other thing we have to figure out is the neutrons. 6.9 rounds to 7. You subtract 3. That leaves you with 4 neutrons in the nucleus. So if we're talking about the charges, remember that the protons carry a positive charge. So if you have 3 protons, you have 3 positive charges. If you have 3 electrons total, then you have 3 negative charges. So before the bonding occurs, this atom is neutral or has no charge. All right, let's switch over here and look at fluorine. Fluorine's atomic number is 9, which means it has 9 protons. And it also has 9 electrons. And once again, we start with the innermost energy level. It maxes out at 2 electrons. So if we start with 9, we place 2, that leaves us 7. The second energy level can hold up to 7 electrons. Actually can hold up to 8, so those 7 right there will place right here. Remember that the second energy level would like to be filled with 8 electrons. It has 7. Fluorine is a larger atom than what lithium is. So with the additional positive charge, actually having 6 more protons and wanting to become stabilized, and the lithium willing to give up this electron, which when it gives up this electron, that energy level disappears. And the outermost energy level becomes the first energy level. It is filled with 2. That stabilizes lithium. So lithium is willing to transfer or let fluorine have its 1 outer electron. But actually, I about fell into it too, guys. I put that third energy level there just to show you that there's a third one out here, which maxes at 18. But this electron actually goes to the second energy level. And it fills the second energy level with a total of 8, which stabilizes it. I drew that line for the third energy level to remind you that it's out there. It holds 18, but because there's not any electrons moving in it, it's really not defined. So this electron would go to the second energy level, which fills it to 8, which stabilizes it. Now, prior to it gaining that electron, fluorine had 9 positive charges because it had 9 protons. It had 9 electrons or 9 negative charges. And before it gained that electron, it was neutrally charged. The positives charges canceled out the negative charges. Now, let's talk about after bonding, after the transfer of electrons has occurred. The proton stays the same. It still has 3 protons, 3 positive charges. But now, once it's allowed that electron to leave, it only has 2 electrons or 2 negative charges. Now it has an overall charge of +1. It becomes a +1 ion, a +1 lithium ion. Fluorine, on the other hand, has gained the extra electron. It still has 9 positive charges, has not gained protons, but now it has 2, 9, it has 10 electrons or 10 negative charges. It now has an overall charge of -1. So fluorine is now a -1 fluorine ion. And opposite charges, positive, negative, attract. So these two ions will now pull together and form a lithium fluoride bond. Now, when you write chemical formulas, the positive ion is always written first before the negative ion. So this is the chemical formula. If you saw something like this with a dash between it, this dash represents one electron being transferred. That's kind of more like a structural formula. And that's more with covalent bonding, actually, not so much ionic. All right, so this is basically ionic bonding. This is how your worksheet online should have been filled out. On the test, I will give you atoms just like are set up here. I will give you the diagrams on probably a CAMI handout or a CAMI post, and you will go in and you will fill all this information out, okay? So there'll be a positive or neutral ion over here, and basically a metal and a non-metal, and you'll show electrons being transferred, and you will do all of this. So this is pretty much what your test will look like for the ionic bonding, okay? All right.